Hello everyone, I'm Mr. Furlong, and today we're going to be doing even more writing of chemical formulas, but this time with polyatomic ions. We've already written some basic chemical formulas, but in this video we're going to take a look at how do we write formulas with polyatomic ions. And you're probably asking yourself, what is a polyatomic ion? Well, if we break this word down, poly means many, atomic means atoms. So this is simply an ion that is made up of many atoms. Remember, an ion is an electrically charged particle, either positive or negative. And we looked at things like sodium and chlorine and potassium, but those were single elements. A polyatomic ion is made up of more than just one atom. These are some of the more common polyatomic ions that we're going to be working with in class. And if we look at, in that first column, ammonium, it's NH4. It's made up of 1 nitrogen and 4 hydrogens. It has an oxidation number of 1 plus. So for these, you would have to have this table with you, and you will have it with you when you are writing these formulas. One thing to take note of, though, is that these ions can never change. So for instance, carbonate under the oxidation number 2 negative is always going to be CO3. It's 1 carbon and 3 oxygens. Essentially, writing these formulas is the same way that we've written the formulas already. It's just that we have a few more elements that we have to work with. So let's jot down a few of these. So let's take a look at silver. Silver, this is one of those B families, but because there's a Roman numeral, we know that it's 1 plus. Nitrate is NO3, and that is 1 negative. So we do the crisscross method. The one goes with the silver, the other one goes with the nitrate. Since they're ones, we don't show them, and so we would just say it's AgNO3. But let's take a look at this next one, silver phosphate. Silver 1, so we know that its oxidation number is 1 plus. Phosphate. Phosphate is under the oxidation number of 3 negative. It's PO4. And so it's 3 negative. Again, we do the crisscross method. The 3 goes with the silver, the 1 goes with the phosphate, and so the formula is Ag3PO4. Remember that PO4, we can't separate those elements. It's a polyatomic ion. Let's do another one. Hydrogen, there's no Roman numeral, but we do know that based on the periodic table, it would be a 1 plus. We need to find sulfate, which is under 2 negative. There you see it's SO4, and that is 2 negative. We do the crisscross method. The 2 goes with the hydrogen, the 1 goes with the sulfate, and so we have H2SO4, and we have the chemical formula. Let's take a look at this next one. Aluminum, based on the periodic table, we know its oxidation number is 3 plus. Hydroxide, we find that, and we see that it's just OH, and it has an oxidation number of 1 negative. So the 1 goes with the aluminum, and the 3 goes with the hydroxide. And so we would write this as Al. Now you might think we would put this OH3, but that would be incorrect because we actually have 1 aluminum and we have 3 OH polyatomic ions. If we look at this, it's simply saying we have 1 aluminum, 1 oxygen, and 3 hydrogens. But we really have 3 oxygens along with those 3 hydrogens. So when we're using polyatomic ions, we have to use parentheses whenever we have more than 1. So I'm going to put the aluminum and then in parentheses the OH3 to show that we have 3 OHs in aluminum hydroxide. Sometimes, however, we can combine 2 polyatomic ions. So for instance, ammonium is NH4, and we know that it has an oxidation number of 1 plus. Phosphate is under 3 negative. That's a PO4, 3 negative. So again, we still do the crisscross. We put the 3 here, and the 1 goes with the phosphate. So we write out ammonium, NH4. We have to show there's 3 of them, so we have to put that into parentheses. Remember, anytime you have a polyatomic ion and you have more than one, you got to have parentheses. We only have 1 phosphate, so that would just be PO4, and we have ammonium phosphate. Let's do another one with ammonium. We know that we have NH4 is 1 plus, and we're combining that with sulfate, which is SO4, and that is a 2 negative. So the 2 goes with the ammonium, the 1 with the sulfate, and we would write this as NH4. Now we have to show 2 of them, so we're going to put that in parentheses, put the 2 on the outside of the parentheses, and then SO4, ammonium sulfate. So as you can see, we are writing the formulas the same exact way. We just have to remember 2 things. One is we can't change what that polyatomic ion is, and 2, if we have more than 1 polyatomic ion, we have to put it in parentheses. We're going to spend some time in class, practice writing these, and I can't wait to see you then.